here is my demonstration of, regardless of the density and dropping items in tubes of water or half full of water or that, here's how I know the earth is not rising. Okay, the argument is, if I take this bottle of water and let it go, the argument going on is that it's just stationary. It's neutrally buoyant. We've all seen the videos of those neutrally buoyant balloons. Okay, and that's all these water tube experiments are proving, is neutral buoyancy. Well, we've known that existed for quite some time now. Okay, but if the earth was rising, it then would not matter how far I dropped this water bottle from. It would always act the same, because the earth would have to be rising at a constant rate. So that's how I know the earth is not rising. Okay, because the bottle would act the same whether I dropped it from that height or from this height, and it doesn't act the same. The higher I drop it from, the more damage. If the earth were actually rising, and no matter where I let go of this bottle from, the earth would be impacting it at the same rate, and therefore it would act the same regardless of the height I dropped it from. Thanks. Have a great day.
Okay, so hopefully I've managed to get the recording of Daniel Pratt's video. This is just a little response. Firstly, I just want to say thanks, Daniel. It's good that people are thinking about stuff, and it gives the opportunity to have the discussion, because at the end of the day, that's all that it can be. So we've seen your little video there, and you know, you're talking about the bottle, and if you let it go from there, then there's a little impact. If I let it go from here, there's a bigger impact. So therefore, you say the earth would have to be accelerating, and yada yada. Well, here's the thing, Daniel, in this postulation, the way I'm considering it right now, it's a total opposite. So here, if we have a reference frame, right, we'll call this earth, right, just for the sake of it, and we have an object attached to earth, right, and it's moving, right. Maybe not the best thing because it's going to slide off, right? Well, let's try something else, we'll use that. So we've got an object that's attached to earth, and earth's moving, right? Now the earth's moving at its set rate, constant velocity, say, which would be, we'll say if we're talking, say, 1,000 miles per hour. So the earth and this thing that's attached to it's moving 1,000 miles an hour. As soon as that's no longer attached to that, right, it's going to start a process of decelerating, it's going to get slower, right? And if it's not too far away from the surface of the moving reference frame, then as it comes off, there's a slight impact, right? Slight impact, because it's not had a chance to decelerate, right? It's still moving relatively, you know, quickly in regards to the reference frame. It's not going to lose that much of its speed, right? I mean, these things are just basic physics. If I'm now standing up here, you know, again, we're looking at this as if we're vertical. Now if I'm standing up here and I'm holding this out here and I let it go, right, then it's going to start its deceleration process. It's going to get slower and slower and slower, and the earth would come up and hit it harder, right, because it's got a bigger gap, there's more time for it to decelerate. If it's out here, you know, and it's just gone the same rate, right, like if I had a craft that was moving at the same rate, then that's what would happen. But when I step over here or I drop something off of this, it begins a process of decelerating as this moves continually at its same speed. So as it's getting slower and slower, this is just going to come up and hit it with more impact. If you were witnessing that, it would give you the impression that this thing was getting faster and faster and faster. The reality would be that that would be getting slower, and the reference frame moving at its constant velocity, it would appear to you that that's the thing that's getting faster, when the reality would be that that's getting slower. That's physics, that's what happens. When it's no longer attached to a power source giving it its motion, right, it's going to lose its momentum. So if the earth was in uniform motion here, and I let it go, deceleration is very minimal impact. If I let it go from up here, more time to decelerate, more impact. Now you would get maximum impact when that object reaches 0 terminal velocity, and the reference frame was at its full speed. So other examples of that, again, you know, showing it laterally, people understand from maybe driving cars and stuff. So if you've got, you know, one vehicle and another vehicle and you're racing and you're both doing the same speed, right? So we'll call this one earth, right? So we'll say they were bumper to tail, right? And this car's called earth and this car's called object, right? And they were both moving. Let's say this one doesn't have any power, right? And they're both moving at 100 miles an hour. This one's pushing this one at 100 miles an hour. If I then put power to this one and I accelerate it, say 102 miles an hour for a period of time, and then I get back to 100 miles an hour, I've now created a gap, right? Now if I then decelerate this one from this distance, the impact's going to be minimal, right? If I'm further away, so say this is pushing this at 100 miles an hour, then we put power to this, we take it to 105 miles an hour for a longer period of time, then we bring it back to 100 miles an hour, then we're going to have a gap like that, a bigger gap. Now if I switch the power off of this, it's going to start losing momentum, and this one's going to continue its 100 miles an hour, while this one, the longer the gap it has, the more time this has to decelerate, right? So if I had enough space, and this was doing 100 miles an hour, this was doing 100 miles an hour, I had enough space for that to decelerate to 0, that being no miles per hour, and that going 100 miles an hour, maximum impact, right? So in that scenario we can comprehend it, that's the mechanics of motion, that's how things operate, right? Let's try that again now, you know, just we can invert it any direction, but let's now say, how do we work this out now, that this is stationary, and this is stationary, right? We're just going to assume that's stationary, then I come along and I apply pressure and I take that up to there and I let it go, right? You have to assert that this thing now accelerates towards the earth. How's that? How does that work? How does that work? These two are connected on your stationary earth. Everything's stationary apparently, and I now apply force to take that to a height and I let it go, and you say it accelerates and comes down, crashes into the earth. And the higher I take it, the more time it has to accelerate, so it's getting faster and faster and faster, maximum impact. So what makes it get faster? How mechanically, in the rational, mechanical, real world, how do you make that thing which you're saying stationary? And I take it to here, now I'm stationary, so I'm on a ladder. Right, that's connected to your stationary, so everything's stationary and I'm holding it there and it's stationary and I let it go. What are you saying makes it go like that and hit the earth? Because you need something. You require something. Right? What I'm saying to you is demonstrable. You can comprehend this. You've driven a car. If you're behind a car doing 70 miles an hour and you've got a tiny gap, and that car's doing 70 miles an hour and that one takes its foot off the accelerator and goes to 69 miles an hour, you're going to bump into it very slightly. It's decelerated enough for you to give it a slight nudge. If he's half a mile up the road and he lets off and comes to a rolling halt and you're still going your trajectory, wallop, you're going to smash into it and cause maximum damage, maximum impact. This can be understood very simply. And again, I can only thank you for making the video, and I encourage other people to continue making videos and asking these questions, because, as I say, you know, with this stuff, it can be demonstrated, it can be comprehended, but stationary objects and other stationary objects magically accelerating, I don't comprehend how that functions. I don't know what aspect of reality you would garner that sort of postulation from. It's preposterous. It's totally and utter lunacy. But thanks, hopefully that helped to understand that. You know, it's not that difficult. Cheers.